Welcome. This video will discuss Amazon EC2 cost optimization. Amazon offers different pricing models to choose from when you want to run EC2 instances. On-demand instances are eligible for the AWS free tier. They have the lowest upfront cost and the most flexibility. There are no upfront commitments or long-term contracts. Dedicated hosts are physical servers where instance capacity that is dedicated for your use. They enable you to use your existing software licenses, such as Microsoft SQL Server, and dedicated instances are instances that you run in a virtual private cloud on hardware that is dedicated to a single customer. Reserved instance enables you to reserve computing capacity for 1-year or 3-year terms with low hourly running costs. The discounted usage price is fixed for as long as you own the reserved instance. Scheduled reserved instances enable you to purchase capacity reservations that recur on a daily, weekly, or monthly basis with a specified duration for a 1-year term. Spot instances enable you to bid on unused EC2 instance capacity, which can lower your costs. The hourly price for a spot instance fluctuates depending on the supply and demand. Your instance runs whenever the bid exceeds the current market price. It is important to note that per second billing is available, but only for on-demand instances, reserved instances, and spot instances that run on Amazon Linux or Ubuntu. Each Amazon EC2 pricing model provides a different set of benefits. On-demand instances offer low cost and flexibility with no long-term contract. Spot instances provide large scale at significantly discounted price. Reserved instances are a good choice for predictable or steady state compute needs. Dedicated hosts are a good choice when you have licensing restrictions or need to meet compliance or regulatory requirements. Let's take a closer look at the pricing options and some of the more common use cases. On-demand instance pricing works well for spiky workloads, or if you need to run a test or maybe an application for a short amount of time, for example, during a development or testing period. If your workloads are unpredictable, short-term, or spiky, on-demand instances are a good choice. Spot instances are a good choice if your application can tolerate interruption, and possibly have the spot instance be terminated with a 2-minute warning. By default, when interrupted instances are terminated, you can configure them to stop or hibernate instead. Common use cases for spot instances include fault-tolerant applications such as web servers, API backends, and big data processing. Reserved instances are a good choice when you have a long-term workload with predictable usage patterns, such as servers that you know will want to run for over a consistent amount of months or years. Dedicated hosts are a good choice when you have existing per socket, per core, or per VM licensing, and you must address specific corporate, compliance, and regulatory requirements. To optimize cost, you should consider the 4 pillars of cost optimization. First, you must right-size. That is, choose the right balance of instance types. It's important to notice that when servers can be sized down or turned off and still meet your performance requirements, that this affects cost. Second is increase elasticity. Design your deployments to reduce the amount of server capacity that sits idle by implementing deployments that are elastic, such as deployments that use automatic scaling to handle peak loads. Third, choose optimal pricing. Analyze your current usage patterns so that you can run EC2 instances with the right mix of pricing options. And finally, optimize your storage choices. Reduce unused storage overhead and choose less expensive storage options if they can still meet your storage performance requirements. Let's look at the right sizing in more detail. AWS offers more than 60 instance types and sizes. The broad selection enables customers to choose the instance that best fits their workload. It can be difficult to know where to start and what instance choice will be best for your application. Review your deployed resources and look for opportunities to downsize when possible. Use Amazon CloudWatch metrics to review CPU, RAM, storage, and network utilization and identify the instances that could be downsized. Select the most cost-effective instance available that still meets your performance requirements, and if your usage pattern will be consistent, purchase reserved instances. Let's take a closer look at increasing elasticity in more detail. Elasticity is one of the central principles of the cloud, but customers often go through a learning process to operationalize elasticity to drive cost savings. One form of elasticity is the stop or hibernate Amazon EBS-backed EC2 instances when they are not in use. Common candidates for stopping or hibernating are non-production environments, development workloads, or test workloads. For production workloads, configuring more precise and granular automatic scaling policies can help you take advantage of horizontal scaling to meet peak capacity needs and to not pay for peak capacity all the time. Let's take a look at how to identify the optimal pricing model, which is the third pillar of cost optimization. The available pricing models were discussed earlier in this video. You can combine multiple purchase types to optimize pricing based on your current and forecast capacity needs. You are also encouraged to consider your application architecture. For example, does the functionality provided by your application need to run on EC2 virtual machines? Or could you significantly reduce your costs by using AWS Lambda instead? AWS Lambda is discussed later in this module. Finally, let's review the fourth pillar of cost optimization in more detail: optimizing storage choices. It's a best practice to try to reduce costs while also maintaining storage performance and availability. One way you can accomplish this is by resizing EBS volumes. For example, if you originally provisioned a 500 gig volume for an EC2 instance that will only need a maximum of 20 gig of storage space, you can reduce the size of the volume and save on costs. There are also a variety of EBS volume types available. Choose the most cost-effective type that still meets your performance requirements. Customers often use EBS snapshots to create data backups. However, some customers forget to delete snapshots that are no longer needed. Delete these unneeded snapshots to save on storage costs. Finally, identify the most appropriate destination for specific types of data. Does your application need the data that it uses to reside on Amazon EBS? Would the application run equally as well if it used Amazon S3 for storage instead? Configuring data lifecycle policies can also reduce costs. For example, you might automate the migration of older, infrequently used data to more cost-effective storage locations such as Amazon Simple Storage Service, Glacier. Done correctly, cost optimization is not a one-time process that a customer completes. Instead, you should routinely measure and analyze your systems so that you can continually improve and adjust your costs. Tagging helps provide information about what your resources are being used and by whom and for what purpose. You can activate cost allocation tags in the Billing and Cost Management console, and AWS can generate a cost allocation report based on your assigned tags. Apply tags that represent business categories to organize your costs across multiple services. Also consider using AWS services such as AWS Trusted Advisor, which provides real-time guidance to help you provision resources that follow AWS best practices. Encourage teams to architect for cost. AWS Cost Explorer is a free tool that you can use to view graphs of your costs. Finally, cost optimization efforts are typically more successful when the responsibility for cost optimization is assigned to an individual or a team. Thank you for watching. We'll see you in the next video.